In this video, we'll see the rule for differentiating powers of x. Now, in the top left-hand corner, I've written if f of x is equal to a times x to the power of n, then f dash of x equals to n times a times x to the power of n minus 1. Now, this can also be written as if y equals to a times x to the power of n, then dy dx equals to n times a times x to the power of n minus 1. Now, first of all, those two lines are saying exactly the same thing. They are simply two different notations you need to be familiar with at your IB Math Studies exam. So let's get started and go right ahead and work through a couple of examples. So, as example 1, let's say we have to differentiate f of x equals to 3x to the power of 4. Well, to do this using this rule and comparing it to a times x to the power of n, we can see that a is equal to 3 and n would be equal to 4. So simply using that formula at the top, I can go ahead and say f dash of x, the derivative function, is equal to 4 times 3 times x to the power of 4 minus 1. 4 times 3 is 12, so I can write this as 12 times x to the power of 3, since 4 minus 1 is 3. And there we go. We've just differentiated that function. Let's look at another example. Let's say we're given the function f of x equals to x to the power of 5. Now, the first thing to point out here is that when we write x to the power of 5, that means 1 times x to the power of 5. In other words, in this instance, if you need to compare it to the formula f of x equals to a times x to the power of n, then a would be 1. So, using that, we can now differentiate and say that f dash of x, the derivative function, is equal to 5 times 1, which we don't write, times x to the power of 5 minus 1, which leads us to 5 times x to the power of 4. And we're done. Let's look at another example. Let's say we have to differentiate y equals to negative 2x cubed. Well, in this case, what I'll do, because I'm given the equation of the function's curve, y, in other words, I can see it starts with y and not f of x, I'm going to use the y and the dy dx notation, but it makes no difference. To differentiate this, I can go ahead and state that dy dx equals to 3 times negative 2 times x to the power of 3 minus 1. 3 times negative 2 is negative 6, and that multiplies x to the power of 2. And there we go. Okay, let's look at one more example. I'll just write exercise 4 there. Let's say we have to differentiate f of x equals to 6x. Well, in this case, the key or the trick really is to see that 6x is the same thing as 6 times x to the power of 1. We just never write the power of 1 when we write x. So do keep that in mind. Now we can use our rule for differentiating powers of x, and we can go ahead and state that f dash of x, the derivative, is equal to 1 times 6 times x to the power of 1 minus 1. Now that's equal to, well, 1 times 6 is 6 times x to the power of 0. And here's something important to remember. X to the power of 0 is always equal to 1. So this is 6 times 1, which equals to 6. And there we go. Remember, x to the power of 0 is equal to 1.